Hello everyone, I am Parmita, back with a new series of videos which explains the basics of neural network. The last series of videos were about the classical machine learning methods. This time we will try to understand the neural network. Slowly and steadily we will reach to a position where we can create the complex network for various use cases. But before that, we should be able to understand the basics of it. So, a neural network is an interconnected system of perceptron. So, it is safe to say that the perceptron are foundation of any neural network. The perceptron can be viewed as a simple mathematical equation. It's actually a single layer in a neural network which is made up of 4 different parts. The input values or one input layer, the weights and the bias, the net sum and the activation function. The perceptron is a simple algorithm which when given an input of vector x of m values, that is x1, x2, x3, often called as the input features or simply features, output is either 1, that is yes, or it is 0, that is no. Mathematically, a perceptron is defined as an fx which is equal to 1 when your input is greater than 0 and 0 otherwise. And the input is given with the equation of wx plus b, where w is my weight and wx is the dot product and b is the bias. If you remember the elementary geometry, wx plus b defines the boundary hyperplane that changes the position according to the values assigned to w and b. If x lies above a straight line, then the answer is positive, otherwise it is negative. The perceptron cannot answer a maybe situation. It can answer either in 1 or 0. If you just remember the different types of functions that we used in our elementary maths, you can say that this is similar to a step function where we say my output can either be 1 or it can be 0. Now, if I talk about we engineers, we can say that our life is based on only 2 important things. One is 1 and other is 0. So, these are the binary inputs. And if I talk about the basic unit of any hardware, these are the gates. Let's try to understand how a AND gate functions. If I see the diagram of AND gate or the equation how the AND gate functions, it's like the output of an AND gate is plus 1 if and only if all the inputs are positive, that is greater than 0. And output is 0 if at least there is one positive value or a non-positive value. So it's like 0 and 0, if you AND it, the output is going to be 0. 1 and 1, if you AND it, output is going to be 1. But if any one of them is non-positive or a 0 value, your output is also going to be 0. We want to see that whether we can train a machine learning algorithm, namely a simple perceptron, to learn such gates. But before we jump into the code and start an ML model or make it learn, let us understand few more terms. Next important term which I would like to share is the linear separability, and then what is the issue with the XOR gate. Let's talk about a one-dimension value. You are on a number line. You can take only 2 numbers. Now there is 2 possibility. You can take 2 different numbers or you can choose the same number. If you choose 2 different numbers, you can always find another number in between. This number separates the 2 numbers you choose. Hence we can say that this is linearly separable. If both the numbers are same, you simply cannot separate them. They are same. They are linearly inseparable. And actually, it is not only linearly, they aren't separable at any point of time by any method. Then let's talk about 2 dimension. Let's say if I talk about this diagram, you can see that there are certain circles in the right side of my dotted line, and in the left side or in the below side I'm having certain crosses. These two data points can be separated by a single line, and hence it is called a linear separable problem. This is linearly separable. Now let's talk about this particular graph. Here we would like to separate the point 1, 1 from the other points. We can see that there exists a line that does this. In fact, there are infinite lines. So these two classes of points are linearly separable. The first class consists of the point 1, 1, and the other class consists of 0, 1, 0, 0 and 1, 0. Now let's understand a separate case altogether. This is a point where you can say that there are two red points and two black points. In this case, you cannot find a single line which can separate these. If I draw a line this way, one of the red points comes this way in this particular plane, and this red point will go in the separate one. Hence, I can say that these particular data points, I cannot separate them linearly. Let's first move into the three-dimensional problem. If I take these points, and you can see all are blue points and there is a single point which is a red point. There is a dashed plane which separates the red point from the other blue points. So it is linearly separable. If bottom right point on the opposite side was also a red point, it would become linearly inseparable. Now let's try to understand what is a XOR problem. If you remember how a XOR gate works, it's like if I have the input of 0, 0 or 1, 1, or in other words, if I say I'm having an even number of inputs, both can be negative or both can be positive, my output is going to be 0. But in the other case, if one of my input is 1 or one of my input is positive, then my Y becomes 1. So this is the graphical representation of the AND gate where I am having 2 points this way and 2 black points. This particular problem is quite similar to the problem which I was discussing for this particular graph, and hence this is called as a XOR problem. So now, at least at the high level, we know what is a perceptron, why perceptron is similar to a step function, what is an AND gate, why AND gate is linearly separable. Then we have also understood what is linearly separability, what is the XOR problem, and why those points in the XOR gate is linearly inseparable. Now I would like to jump off to the code so as to train a simple perceptron or a neural network so that we can make it learn an output is similar to that of an AND gate. But before that, I would like to show you the graph or how my equation is going to look, or what all are the cost function that we are minimizing so as to reach to my output level. We are trying to train a gate from scratch. So if you see this particular diagram, I am having the inputs as x1 and x2, and x0 is equal to 1, which is the bias. You will also notice that I am using a sigmoid function instead of a step function here. The reason is that during the back propagation, we need all the functions that we have used during the forward pass to be differentiable. Please do not confuse yourself with these terms like that of the back propagation, sigmoid functions and forward pass and all. We will be discussing each and everything in detail in the following videos. Now the step function is not differentiable as it breaks at the point 0 when the input is 0. So I have used a sigmoid function which is differentiable all across and is continuous. Then I am using the binary cross entropy cost function, which is nothing but minus y log of y hat minus 1 minus y into log of 1 minus y hat, where y is my output, actual output, and y hat is my predicted output. So this is the cost function we are using. We would try to minimize this cost function so that we can reach to our output. Let's move to the code part. Let's see how the code works and we will see how the output of the code is. In the initial part of the code, we will be using certain mathematical operations, certain Python packages. I think you must be aware of these type of packages. We would be using the NumPy. Then we are using, for the plotting purposes, we are using the matplotlib, and we are also using the MPL toolkits for various type of plotting. As we have already discussed that we are using the cross entropy as our cost function. So I'm just defining that cross entropy. So this is how we are defining a function with my parameters is y hat and y. This is if y is equal to 1, it is returning minus np.log y hat, and otherwise it is returning this particular value. This equation I have already shown you in my slides. Then as I am using a sigmoid function, I am also defining a function sigmoid, which is nothing, this is just nothing but the equation of my sigmoid, that is 1 divided by 1 plus e to the power minus z. You know that while the backpropagation works, we need the derivative of each and every function, and hence I'm also defining the derivative of my cross entropy and derivative of my sigmoid, that is derivative cross entropy and derivative sigmoid. So this is just the output of my derivative of sigmoid function. This is the output of my derivative of my cross entropy function. Now I'm trying to generate my own data. My data looks like 0, 0, 0, 5, 5, 0 and 5, 5. Now if I talk about mimicking an AND gate, my AND gate will always give a positive output if my both of the inputs are positive, and hence my output is 0, 0, 0, 1. That means it is giving 1 only in this case where both my inputs are 5 and 5. I'll not go much detail into the code of the matplotlib, but I'll just show you how the code works and what is the output of the code. What I have done, I have just created a simple scatter plot which is actually giving the graphical representation of an AND gate, and you can see that if my if my input is 5 and 5, the label we are saying it as class 1, and for all the other cases we are showing it as class 0. So this is the AND gate and the output of that particular code, where these three are my class 0 and this is my blue dot is my class 1. So instead of the code, if I just ask you functionally if this is linearly separable or not, I think most of you have the answer it correct, that it is yes. This is because if I just draw a simple line here, then my points are separable. Therefore, I can easily separate these points through a linear line, and hence it is linearly separable. Again, we can jump off to the code. We are considering the low and the high range of our random weight generation. You should always remember that we have to consider this range as small. Why this should be small, we will also discuss in the following lectures. There is a certain values, certain parameters or certain terminologies which is known as the learning rate. It should be small, and also it should not be very small or very high. Those reasons we will discuss in the following videos. Then there is a concept of epoch and then the batches. It is, you can just understand for now, these are the different iterations that we are doing in our neural network so that we can train it in a perfect way. With each and every iteration, we are getting a cost function. That is, you can just understand it is nothing but the difference between your predicted value and actual value. We are trying to adjust the weights and the biases each and every time so that we can have the minimum difference is my predicted and the actual value. Less the difference, better my network is and better the accuracy of the model. So this is the code of how we are doing the training. So I'll just give you a high level like how the code works. So first of all, we are computing the Z, and by Z I mean that it is the input to the sigmoidal unit. So it is nothing but my weights multiplied by x, that is weight 1 into x0 plus weight 2 into x1 plus weight 0. Then I'm applying the sigmoid function. I have already discussed that we have defined a sigmoid function above as a Python function. So I'm just calling that function, and my input to that function is this particular z, which we have already defined. Then we are computing the binary cross entropy. That function is also we have defined. So we are calling the cross entropy function, and my parameters are y hat and yi. Then we have to compute the gradients for the error function with respect to all the three learnable parameters. And when I talk about learnable parameters, it is the weights of the network. So we are calling the derivative cross entropy, that is y hat and yi, and then we are just multiplying it with the derivative of the sigmoid function, because my input is also going to my derivative of the sigmoid function. So we are updating the parameters each and every time. We update it in such a way that my output is going to be the best, or it should be very much near to my actual output. What is gradient descent? What is backpropagation? What is stochastic gradient descent? We will discuss in detail in the following videos. So this is nothing but the mathematical formula how we are defining the W0, W1 and W2. Now, after every 500 epochs, we can easily visualize the things. I'll just quickly take you to the visualization thing and how it looks like, and how my model is now trained so that it can mimic a AND gate, or give me the output which is similar to a very simple AND gate. So you can see these three inputs in the first, these three outputs. In the first part, we are trying to define a simple hyperplane or a line which is actually separating these three red points and one blue point. Then we are trying to train it where we are trying to define a hyperplane, a plane through the input space, and that is now trying to separate these three red points and one blue point. And in third point, when we are allowing my network to have the sigmoid as an input and try to learn it slowly, and by it I mean the model, when it tries to learn the things slowly, this is the type of output that I get. You can also see that the graph that you get, it is similar, it is little bit similar to the S, so it can be more S with the change of the various parameters. But yes, now with this particular learning mechanism where we are using a simple sigmoid function and then changing the W and the B, that is the weights and the bias, we are now able to train our model in such a way it can give the output which is similar to my AND gate. I'll be sharing this code. I'll give you the GitHub link. I'll be sharing the code. You can go through the code. Any type of questions, please ping me. You have my email ID. If not, you can directly give the comments on the YouTube channel. So I think congratulations to all, because now you are pretty much clear with what is a perceptron, what is the basic building blocks of the neural network, how it works. We have also built a simple code using simple Python and Python functions and some maths, and now my model is able to say what is the output of an AND gate. So I think there were many things to learn. I know this topic is little bit out for people who have worked on the machine learning algorithms. These things are quite new to them. It would take time to grasp, but yes, slowly and steadily we are going to reach that particular point. Any questions, please let me know. I'm always here to help. Thank you. Bye-bye.